Process of sizing our drainage is going to be similar to our high water line verification equations. Remember the SES curve number method? Well, we can conservatively set our hydrologic soil group as D and use that to estimate our curve number based on the tables for various land use types. We can then calculate Q, our runoff depth, using the equation P minus IA squared over P minus IA plus S, where we have our storage S, our initial abstraction IA, and our P from our storm characteristics as our cumulative total rainfall. And this will give us our runoff depth in inches. Now, the capacity of our standard drainage will be the area of a trapezoid of the depth of 30 centimeters, width of 50 centimeters at 3-to-1 slopes, so 30 centimeters along the bottom, which is 1,200 centimeters squared. And for both sides of this abutment, we can capture 0.24 square meters of water per meter. Now, to crudely estimate our runoff area, we can just take our runoff depth of Q times our width, our design width, which is going to be the amount, the width of the slope that is actually going to be capturing runoff. Assuming all of this runoff goes into the drainage, we can then, for example, calculate a Q of 3 inches or 0.076 meters of over a water with a drainage design width of 5 meters. We have an inflow area of 0.38 cubic square meters per meter, which is greater than our 0.24. So we would actually need to increase the area of our drainage. Now, this isn't a perfect one-to-one match. The water is going to be running at different speeds over different land covers, so it's going to be running much faster in the drainage and much slower over the land. However, this is a conservative estimate to compare them one-to-one because we are also then assuming the water is being carried away at the same rate that it's coming in, and we have our steady state. If you wanted to really sharpen the pencil on this calculation, we could look at the difference in wave velocity at, over the ground, over the runoff versus within the actual drainage, and that would be able to refine our drainage design a little bit better. Now, in the next lecture, I'm going to talk about groundwater drainage, and it's going to be via text, and I'm going to give some examples for how you can mitigate groundwater issues if that is going to be a problem on your site.